Let me start off with number 1. Feel free to jump in with any questions that you guys have. Okay. Okay, so first up is make sure that we know law of cosines. These will not be given to you, so make sure that we memorize these. Okay, so I like to go ahead and just categorize what I'm dealing with here, or maybe if you want to just go ahead and draw the triangle. And you know, your triangle may be different than mine, which is fine. Okay, so this is angle, side angle, right? We're dealing with 2 angles here. When you're dealing with 2 angles, you know it's going to be an easy law of sines. Okay, these are the ones you've already demonstrated that you can do from the check-in quiz. Okay, so all we need to do is, well, if you have 2 angles, we can find that third angle relatively easily. Subtract from 180, and the rest we could just use law of sines. So angle A, 180 minus 83 minus 36. Good. Oh, and also, by the way, the only time you're going to have 2 triangles, potential for 2 triangles, if it's side-side angles. So anything else, you can always just cross out that second triangle. There won't be a second triangle unless it's specifically side-side angle, and we go through our test for ambiguity. Right? All right, so we're basically looking for lowercase c and lowercase b. Set up using proportions here. B over sine 83 is equal to 15 over sine, yeah. Cross multiply. Enter into your calculator. Okay, good so far? All right, so now we're moving on to solving for side C. Cross multiply. Calculator work. All right, any questions here? No? Okay, all right, number 2. Angle A, side B, and side A. All right, this, what category is this going to be? Yeah, yeah. Which means we gotta be careful that we have to potentially go through that test, right? There, we got to do that vertical height. That vertical height is not part of the triangle, but it is gonna be how we determine what's gonna happen with this free swinging side, right? Is it going to settle as one triangle? Is it gonna be 2 triangles, or is it gonna be 0 triangles? So this is gonna be our guide to know where to put this hanging side here. But just remember that this still falls under the law of sines. Okay, there's no law of cosines here. Law of cosines is only for side angle side and side. Law of sines will allow us to solve this problem, even though this is a longer one potentially because of that possibility of 2 triangles. But first, we need to know what's going. how to judge that 7, right? We don't know where that 7 is going to go yet. So I'm going to use sine to help me find that h. So there's a right triangle. I'm forcing a right triangle here to figure out that vertical height. So how would you set this up?
Sine 34 plus h over 11.
Good. Okay, so we're going to solve for h, and that's going to help us know what to do with that 7. Okay, h equals, okay, 6 point. So this is 6.151, this is 7. 7 is longer than 6.151, but it's less than 11, so not only can it sit here, but it could also sneak inside here and create a second triangle. Okay, so everybody see that? You don't have to write this down, but I just want to kind of convince you that this is how we determine whether we have 0, 1, or 2 triangles. Everybody okay so far? Okay, so we know there's 2 triangles here. And we'll do one at a time. Okay, we'll do the more obvious one. The more obvious one is the 7 out here. Okay, we're going to solve this triangle first using law of sines. And after we get done with this, then we can shift our attention to the second triangle. Okay, so first things first. Well, I have a lot of information involving A, so whatever I set up, I have to involve A. I'm going to target B first. So I'm going to solve for angle B by using sine here. Cross multiply. Get that decimal value. Know that anytime you're trying to find an angle, you got to do inverse. Okay. 11 sine 34 by 7. Okay, to get a more accurate read, what I like to do is once I get that value, I like to use second answer so that it pulls all that value in and kind of gives me a really accurate read of that angle. Now I can round it through decimal places. 61.489. All right, good so far? Okay, so I'm going to fill that in here. That third angle is now a lot more achievable. Subtract from 180. 180 minus 34 minus 61.489. Okay, so let's see what I have now. Okay, one last missing piece, that's side C. Side C, I can go through law of sines again. Cross multiply, solve for C. $12.461. Okay, how are we doing so far? Good. No questions? All right, so that's the first triangle. Okay. We know the second triangle is going to look a little odd because it's going to be kind of over here. It's going to kind of create a obtuse triangle. So I'm going to draw that out here. Right, this hanging side is going to find its way over here potentially as well. So I'm creating that second triangle. Everything in here is going to still apply. The angle A, B equals 11, A equals 7. We can fill all that in. But there's something that we can carry over from that first triangle besides these values that they give us. And now the focus turns to getting that angle B. That angle B, there's a special relationship here. Okay. Not as easy as just being the same angle measure. We can tell they're not, right? One is acute, the other is obtuse. But what's that relationship here between these? Good, 180. Okay, so we know that these are supplementary angles. If you can use that information from that first triangle, you're going to have an easy time with this second triangle. This is going to be an easy one to solve. But we got to make sure that we can get to this point, though. Okay, let's find angle B. What'd you guys get?
I got 118.
Mm-hmm. Okay, I'll fill that in. So once you have two angles, you're gonna have an easy time here because I can find that angle C just by subtracting from 180. $27. And then the final missing piece is that side C, and we'll use law of sines once to get to that side C. I'm sorry, my bad. C is over here. So 20 sine of 27.4. Okay, cross multiply. $5.778. Questions with 2? No? All right, let's go to 3. Yes.
I just had a quick question. For on number 3, so I got 816 equals cosine 2. When I tried to inverse it, I did like cosine -1 equals 816. It said
Yeah, I think the way you combine those numbers have to be very specific. So let me go through that. Number 3, right?
Yeah.
Okay, I'll go through that. Okay, so first things first, we recognize this as side. Even without looking at the triangle, we know this is going to be a law of cosines because it's side. So we know we're going to start with law of cosines. Law of cosines, we'll just get that one missing piece that we need, and the rest we'll finish off using law of sines. You know that only side-side angle has any chance of giving you a second triangle, so there's no need to worry about the second triangle here. Okay. Okay, how do we know where to start? Yep. What's our largest angle going to be? Yep, 29, which will tell us it's B. Good. Okay, so now let's practice building our law of cosines. You know that law of cosines, you want to choose the one with B. I have a handout there if you want to pick one out. So you know that you're going to be bookending both sides of your formula with letter B, because that's what you're focused on. Everything else in between will be involving A and C. So I can just go ahead and do that. Looks a little bit like Pythagorean theorem. Okay, so hopefully we're not struggling to create these law of cosines formula. Okay. So from here, we're going to go ahead and replace every value that we have that we can find. B is 29. Okay, any questions up to this point? Okay, this is where we got to be careful. These numbers are not all going to merge together. There's an order of operations that's going on here. These are free to move, but this is stuck to cosine of B. So this coefficient is going to be with cosine of B, but these numbers are free to move. Now keep your big picture in mind. The big picture in mind is ultimately you want to solve for B. But to solve for B, we first have to kind of get that cosine by itself. So ultimately, we want this by itself, which means that everything, all the stuff has to move. But we got to move it in a very specific order here. We'll do the ones that are least connected to it away from that cosine of B. And then we can clean this up, get it down to a numeric value, then we can divide it over. Okay, so first things first, I'm going to subtract that 24 squared. Move it over to the left side. So 29 squared minus 24 squared minus 19 squared. That's going to get me all the way down to negative 96. Here, negative 2 times 24 times 19. That's going to multiply out to be negative 912. Divide both sides. Okay, now any questions here? So that negative 912 is coming from these numbers here.
Can you show the calculation?
Sure. Okay, so we'll do the, yeah, I'll do the whole thing. So I think maybe some students were asking about that as well. Okay, so I'll do this. So this is 29 squared minus 24 squared minus 19 squared. Right, negative 96. And then I'm going to multiply all these numbers out here. 2 times 24 times 19. That's 912. Yes.
So for angle side, which law would you start with?
Angle side or angle side angle, those are just law of sines.
Okay.
The only thing you're doing with law of cosines is side or side angle side.
Okay. Also, for number 1, would this A equals 15 to lowercase a, would that be the hanging side?
There's no hanging side. There's only hanging side for side angle. There's only going to be one triangle for angle side angle.
Oh, right.
Okay. Yes. Yes, I will. Yeah. Okay, so are we good up to this point here?
Yeah.
Okay, so now I'm going to continue to move towards isolating that cosine in B, I'll divide both sides by negative 912. Okay, good so far. Okay, so now, you know, if we want to solve for an angle, you got to involve inverse. So we're going to bring that involve inverse cosine. Okay, angle B, a 3.958 degrees. Okay, and now the rest of it, we should be able to, remember with law of cosines, you're only doing it once to get to that one missing piece that you need, and the rest of it, you can finish off using law of sines. Okay, so angle B is 83.
You have the answers to these questions.
I do, yeah. So it's on my website, but I'll show it in a little bit as well.
And so for the angle side, there's only ever one solution. Or zero solutions.
For angle side or angle side angle, there's only one solution, right? The only time there's any possibility of two solutions if it's side angle. Okay, which I will go through with number 2. All right, so now I'm going to go through law of sines to figure out one of the angles here. Maybe I'll target angle A. So I'll say sine of A over side A is equal to sine of B over side B. Cross multiply, solve for A, or get that sine A by itself. Now I got to involve inverse here. I'm going to get down to a numeric value, enter that in the calculator. We should be able to get it down to 0.8229. Enter that in the calculator. Inverse sine of 0.8229. .385 degrees. And now it's easy, because if I have two angles, I can subtract from 180 to get that last missing angle. So now angle C is just 180 minus 55 minus 83. All right, questions with side. Yeah.
Question about angle side.
Yeah, let me come back to that. I'm doing a recording here, so I want to get through all this, but I want to do number 4 first, and then I'll stop the recording and I'll come back to number 2. Yeah, because I know that some of you guys came in late. I mean, not late, but this is your lunch period, so I'll go back and do the problems that I haven't gone over with you. Okay. All right. So are we good with 3? Okay. Number 4. Number 4 is a word problem, but don't let that stress you out. You're basically just going to take that information, translate it onto a triangle, and then just pretend like if it was a previous problem, right? You're just going to solve that triangle. Okay, so 3 votes are at C. We got J1, J2, and J3. So from the perspective of J1 can see both J2 and J3. I'm just going to go ahead and draw my triangle here. So J1, J2, and J3. So J1, the angle between the line of sight to J2, so line of sight is here. So the angle from here to the line of sight to J3 is 45 degrees. So they're telling us that this angle JA is 45 degrees. Okay, everybody good with that? To the line of sight to J2 to the line of sight to J3 is 45 degrees. Okay, distance from J1 to J2 is 2 miles. Distance from J1 to J3 is 4 miles. What is the distance between J2 and J3? All right. What type of triangle are we looking at here? Okay, can you be more specific? What type? Which? Not side angle. Say.
Angle side.
Side angle side.
This is side angle side. Do you see how this is side angle side and not side angle? Side angle would be like this, where I have an angle and I have a side and I have a side like this, right? You see how this angle is nicely tucked in between two known sides? We call that side angle side. So if you see side angle side, how do we approach side angle side? Law of cosines. Law of cosines will help us find this missing piece that we need. Okay, we're trying to target J1 here. So maybe I can call this lowercase j1, which is just saying that, J1 and uppercase J, these are going to be the ones that are opposite ends of the formula, and everything in between will be involving J2s, right? Or at least side length. So I know that J1 squared is equal to J2 squared plus J3 squared minus 2 times J2 times J3 cosine of J. Right? We're just building our cosine law of cosines the same way that we do all the other law of cosines. Okay. Well, we have everything that we need. I think we should be able to fill in everything. The nice thing about side angle side is that everything fits in very nicely on the right side. There's not a whole lot of movement that we need to do. Just be careful, though, that when you get to this part, that you have a big set of parentheses protecting that piece so that order of operations from your calculator doesn't mess you up. Okay, so little j1 squared, I named it x, so I'm just going to call it x squared. I'm going to start inserting values for my problem here. Everything is ready for us to enter into the calculator all in one go. There's no need to move things around like in a side problem. Minus parentheses. 2 times 2 times 4. So once I get inside the parentheses, I really don't need another set. If I just do the multiplication in between them, I can save a little bit more, save some of my keystrokes there. Okay. Practice entering that in. You should have got, I'm going to hit that fractional button there to get it down to a decimal value, 8.686. Did you guys get that? You guys okay? Okay, one last step. We need to take the square root. Technically, there's plus or minus, but we're talking about a physical distance, so only positive. questions with 4? Okay, I'll go back and do number 2. But let me show number 1 again. Any questions about, check your answer with number 1 for those of you maybe who are working on it. Number 1 should feel easier because it's 2 angles, so law of sines will help you get to your missing sides. Everybody good with number 1? All right, let me do number 2 from scratch here. Okay, so number 2, I have angle A, side B, and side A. All right, see you in class. Okay. Okay, see you. Number 2, angle A, side B, side A. All right, so here is my angle A. Side B, side A. All right, which category is this triangle going to be? Yeah, so call this side-side angle. So side-side angle, there's that possibility that there could be 2 triangles. We got to go through our ambiguous case test. But keep in mind, you can do this purely by using law of sines. We don't need law of cosines for side-side angle, right? Only side angle side and only side side side. So I'll put that in as well. All we need is law of sines. Okay, so we're going to do a little bit of gather some information. That information is going to come from this vertical height. This vertical height is not part of our triangle per se, but it will help us make some decisions about what to do with that 7. Because that 7 is kind of moving. We don't know exactly where it's going to land. So let's solve for h. How would you set up to solve for h here?
Sine 34 is equal to h.
Good. Cross multiply. Okay, what did you guys get for h? Okay, 6.151. Okay, so you know that this vertical height is 6. Can that 7 swing to the other side? Yes, because it is more than 6 but less than 11, so it's got a chance to sneak in here. If it can sneak in there, that means there's going to be 2 triangles. Okay. So here is how we're determining that. 6.151 is less than 7, which is less than 11. So that's what you're looking for. That's what it's going to tell you whether we're dealing with 2 triangles or not. Okay, are we good up to that point? Okay, so we're going to do 2 triangles, but let me assure you, if we can get that first triangle down, that second triangle will be a lot easier.
How do we know, like, what if it's, if it's 1 triangle?
Okay, so let's say this 7 was a 12 instead. Then it's too long. It's gonna, the only chance it has is to stay out here. Or if it's exactly 6.151, then it's going to be exactly a right triangle. So those are the 2 instances when it's going to be 1 triangle. If it's, let's say this is 5, then 5 is too short, then there's no triangles. We can't do anything with that. Okay, so triangle 1. Let's do the more obvious one here. All right, we should only need law of sines to get all these pieces here. I'm going to target angle B here, right? If I can solve, I want to target B because at least I have some information about B. And I can use angle A as well because angle A and side A has full information about. Okay, solve for B. But first, I want to get that decimal value, but I know I have to involve inverse. Zero 0.8787. Okay, so you guys get 61.489 degrees. Okay, all right, let me put that in. I'm doing everything to 3 decimal places.
But the seminal round.
Oh, you mean the 7th round?
Yes.
Yeah, so my suggestion is you don't want to round too soon. If you round in the middle, you're making your answer less accurate. So the way that you can ensure that you get maximum accuracy is you type in 11 sine 34 divided by 7. See, that's a decimal value there. Don't round it. Keep that value as long as it can be. And so when you hit that sign,
Yes, I did. And just use the answer.
yeah, use this answer button. If you do that second answer, it'll give you as accurate as it can be, and then save the rounding to the end.
Yeah, that's where you're 7.
Oh, so you push that 7 out and you did 0.490. Yeah, that works. Okay, yeah, you can do that. Okay, so I'll make sure that that works. Okay, 61.489. Well, now it's a little bit easier because I can find this angle C by involving 180. What you guys get for angle C? You guys get 8?
84.5.
Yeah, 84.5. So we have one last thing to do with this first triangle, and that is solve for side C. So we go through law of sines again. All right, law of sines will help us get there. $12.461. Okay, so we have full information about triangle 1.
I get just 4, 6, 4, 6, 1.
Oh, that's fine. Yeah, as long as you're. Let me see.
Oh, but I used 0.49, 4948.
You used 84.49?
No, I used 84.5.
Oh. Yeah, try to keep that decimal value, right? Gain more accuracy that way. Okay, so angle C. C sub 1. Okay, so we got one triangle down, one more to go. Any questions so far? Okay, so now the second triangle, imagine how that second triangle is going to look. That second triangle is going to be snuck here. So it's going to create an obtuse triangle, right? Create that obtuse triangle. Let's draw that obtuse triangle here. Here's triangle 2. All these values from the beginning given are all going to carry over. So we got angle A, which is 34. You got side B, which is 11. Side A, which is 7. Okay. We know how the triangle is going to look. We have the initial information, but there's something that we can carry over from the first triangle. Do you know what that is? Or there's the information from the first triangle that's going to help us initially with the second triangle. Has to do with this angle B here. Okay. What's the relationship between these two angles? Are they the same? They're not the same, but there's a special relationship here. What's that relationship? Yeah, they're supplementary. So once you find that angle B, use that to help you find angle B for the large triangle, for the obtuse angle. So 180 minus the angle B from the previous, and that's what's going to make the second triangle a lot easier to solve, because you're making that connection there. What you guys get?
Wow, right.
Mm-hmm. Okay, if you can find angle B, then angle C will follow right along, because 180 minus those two angles will help you get there. Mm-hmm. And then you're one piece away from finishing off this triangle. Law of sines will help you get there. Find side C.
For that question, I put the 11 there instead of there. Does that like make it wrong?
It just makes it.
Because then I subtracted it like the supplementary angle.
Uh-huh.
I used this one instead of B.
Yeah, that makes it more difficult. So if I see side angle, I always like to draw my triangle the same way. That way it just feels more clear. It's not wrong if you do this, but it will throw everything off in terms of you got to do it.
So put the one on that side?
Yeah, if it's side angle, I always like to do it this way, because then it just feels more natural dealing with my hanging side, and it's always the same perspective every time I do it.
Is there a way I should like draw it every time, like a triangle?
Yeah, if it's side angle, I'm always going to draw it this way. Angle, side.
Okay.
Okay.
And the shortest side is the hanging one, right?
The side that is across from the known angle is your hanging one. Right. Okay, yeah, so let me do this here. C over I got side C being 5.778. I want to see as much as you can show me, because I want to see every step along the way.
And law of
Cosines.
law of SSA is law of
Sines.
sines.
Yeah.
not
The only time you have to cosine is side angle side and side. Everything else is law of sines.
How many questions are
Just 4.
And there is ambiguity.